Hi, my name is Mershad and I'm going to talk about the life of Fibonacci. First off, who was Fibonacci? Only the greatest European mathematician of the Middle Ages. His full name was Leonardo of Pisa, or Leonardo Pisano in Italian. No further facts. For now, let's go to the interview of the century. The myth, the man, the legend, Mr. Fibonacci.
Hi, Mr. Fibonacci. My name is Sahir, and we're going to ask you a couple questions. Is that okay?
Yes, I'm very interested.
Okay, so who were you the descendant of?
I am the son of Guglielmo and a member of the Fibonacci family. I am 75 years old.
Where were you born?
I was born in Italy but was educated in North Africa where my father, Guglielmo, held a diplomatic post. My father's job was to represent the merchants of the Republic of Pisa.
That's very interesting. Have you written any books or any guides?
Yes, I have actually.
I've lived in the days before printing, so my books were handwritten, and the only way to have a copy of one of my books were to have another handwritten copy made. Of the books, there still lives copies of Liber Abaci, Practica Geometri, Flow, and Liber Quadratorum. Given that I've only made a few handmade copies myself, it is very rare to find one of my books.
What were you known for, Mr. Fibonacci?
It was in Liber Abaci that I first described
My famous numbers through the problems of rabbits. I was born in Pisa, which is now famous for its leaning tower.
Now, a question. I'm sure everyone asks you a lot. What is a Fibonacci sequence?
That's a great question. The Fibonacci sequence is a series of numbers where a number is found by adding up the two numbers before it, starting with 0, 1. The sequence goes 0, 1, 1, 2, 3, 5, 8, 13, 21, and 34, and so forth.
So do you have a wife or children?
I've been so busy with my studies, I've never really gotten into a relationship or time for that.
I'm sorry to hear that.
When was the Fibonacci sequence created?
The Fibonacci sequence was created the years 1180 to 1250.
That's very cool.
What is a perfect number?
A perfect number is a positive integer.
That is equal to the sum of its proper divisors. The smallest perfect number is 6, which is the sum of 1, 2, and 3. Other perfect numbers are 28, 496, and 8128.
So, this is my last question for you today. Are you proud of the work that you have contributed to society today?
One would hope I made a difference in the world today, but I'm very happy with what I've accomplished, and I'm not feeling so good.
Are you okay? Are you okay?
What is the Fibonacci sequence? The Fibonacci is a sequence of numbers in which each number is the sum of the two previous numbers. For example, 1 and 2 equals 3, 2 and 3 equals 5, 3 and 5 equal 8, 5 and 8 equal 13, and 8 and 13 equal 21, and so on. The Fibonacci sequence can be found in many places, such as novels, films, television shows, music compositions, songs, and nature. It can also be found in various architectures and artwork. For example, a science center in Singapore has tiles arranged to form shapes with sides in proportion of the Fibonacci number. The Fibonacci is also very well known to be found in a variety of plants, such as flowers, fruits, and vegetables. For example, a pineapple. If you look closely to a pineapple, you will be able to see 3 different spirals. One of them rises gradually, one rises moderately, and one rises steeply. The first spiral will have 5, the second spiral will have 8, and the third will have 13. All 3 of these numbers are part of the Fibonacci sequence. 5, 8, and 13. A banana. Also a fruit in which the Fibonacci sequence can be found. If you look at an unpeeled banana, you will see 5 different sections on the outside, but if you cut it, you will see 3 different sections in the middle. Both 3 and 5 are part of the Fibonacci sequence. An apple. If you cut it horizontally, you would be able to see 5 different sections on the inside. One, two, three, four, 5. The Fibonacci sequence can be found in many different places, not just in math, and can be found in nature, architecture, and other many unexpected places. Fibonacci is everywhere.
Hi, my name is Sahir, and today I will be talking to you about the patterns in the golden rectangle. The golden rectangle and the patterns are combined together to make a logarithmic spiral, which is also known as the golden spiral. To make the golden spiral, you cut the golden rectangle into a square, and whatever part of the rectangle that remains is your new golden rectangle. To make the entire pattern, you keep doing the same thing until you finally have a whirling square. In math terms, if the sides of the rectangle have the length of A and B, A is longer, ratio of A to B is equal to the ratio of B to open bracket A minus B close bracket. To create or verify a golden rectangle, you can use the equation A over B is equal to B over A minus B, which you can get 1 or 2 answers from, which should be positive because a length cannot be negative. The points that divide the golden rectangle into squares are on the golden spiral. The golden rectangle pattern affects the form of the golden spiral. The golden rectangle is found in art and architecture and is a shape that pleases the eye. The reason behind this is the golden ratio, which is an irrational number with no end. The golden ratio makes pleasing shapes, and in the case of the golden rectangle, the ratio of the length to the width is the golden ratio. This is how to draw the golden rectangle pattern with the spiral step by step.
Hey, my name is Mershad and I'm going to talk about the Fibonacci Rabbit. In the West, the Fibonacci sequence first appears in the book Liber Abaci 1202 by Leonardo of Pisa, known as Fibonacci. Fibonacci considers the growth of an idealized rabbit population, assuming that a single newly born pair of rabbits, one male and one female, are put in a field. Rabbits can mate at the age of 1 month, so that at the end of its 2nd month, a female can produce another pair of rabbits. Rabbits never die, and a mating pair always produces 1 new pair, 1 male, 1 female, every month from the 2nd month on. The puzzle that Fibonacci posed was, how many pairs will there be in 1 year? If we start in December, we would have 1 young black couple, and then in the next month, that black couple in January would now be able to mate for the next month. So in February, there would be another pair of rabbits, the golden pair. And then for the next month, the month of March, both the black couple and the gold couple would come down. The gold couple would now be able to mate for the next month, and the black couple made a new pair, the red pair. And that is how we would move on. Suppose we let the number of rabbits in the field at the end of the nth month be denoted by Fn. Consider just the new baby rabbit pairs in the nth month. They must be equal in number to the pairs of rabbits that are mature enough to give birth to baby rabbits. This, of course, is precisely the number of rabbit pairs alive 2 months previously, Fn minus 2. Now the total number of rabbit pairs in the nth month is the number of pairs alive in the previous month, Fn minus 1, plus the number of new baby rabbit pairs, Fn minus 2. Thus, we have the following recursive definition for the nth Fibonacci number. F0 equals F1 equals 1, Fn equals Fn minus 1 plus Fn minus 2. And then, so the answer for 1 year would be F12 equals F times 12 minus 2 plus F times 12 minus 1, which would be 55, plus 89, which would equal 144 pairs in 1 year. Real rabbits don't breed as Fibonacci hypothesized, but this sequence still appears frequently in nature, as it seems to capture some aspect of growth. You can find it, for example, in the terms of natural spirals, in plants, and in family tree of bees. This sequence is also closely related to a famous number called the golden ratio.